Welcome to Vinuta's Math channel. This is the fifth video of the DDCO module 1, that is Introduction to Digital Design. In the last video we had seen the theorems and the properties of Boolean algebra. There were 10 properties. So in your examination, examiner may ask to prove some identities or some theorems. Fine. I have taken few theorems, that is x plus x is equal to x into x is equal to x. The B is the dual of A, that is x as it is. How to take the how to find the dual? Replace or with and, so plus with into x as it is, variables as it is. Fine. X plus 1 is equal to 1. Okay, this is one identity. The dual of this is x into 0 is equal to 0, x plus xy is equal to x, and one more, x into x plus y is equal to x. Okay, to start with, let me take the first question, that is we have to prove x plus x is equal to x. So what is the LHS? LHS is equal to x plus x. Next step, x plus x you take as it is. Okay, you write x plus x as it is. I am multiplying it with 1. Okay, I am multiplying it with 1. Next, you take x plus x as it is. In place of 1, what I can write? See here, I am making use of the 10 identities what we have already written and learnt. In place of 1, can I write x plus x bar? Even I can write in place of 1, I can write x plus 1. I'll explain the whole problem and how to remember this, how to solve this, how to I'll give you a clue to remember how to solve this problem. Okay, you can replace this 1 by this x plus 1 and x plus x bar also. But why you have to replace it with x plus x bar? I'll tell you a reason. First let me replace this 1 by x plus x bar. Fine. So I am replacing this 1 by x plus x bar. Fine. Next step, see here, x plus y into x plus z, this can be written as x plus yz. I am using the basic identities to prove x plus x is equal to x. So x plus y, in place of x, x is there. Okay, see here, x plus y, x plus z. In place of x, x is there. In place of y, x is there. In place of z, x bar is there. Fine. So how can I rewrite it? X plus y into x plus z is equal to x plus yz. So I can write it as x plus x into x bar, correct? X plus yz I have to write. In place of y, x is there. X into, in place of z, x bar is there. Fine, which is equal to x plus, what is x into x bar? X into x bar is 0. Fine. What is x plus 0? It is equal to x. So is it proved? Is equal to RHS. Thus it is proved. Understood? Now I'll tell you what are the steps you have to follow. When you were looking into the problem, when I solving, you feel that it is very easy to solve. But when you take this problem and try to solve it on your own without the help or without looking into the answer steps, definitely you will be struck. So I'll tell you a way how to solve this problem. X plus x is there, right? X plus x. In the next step you write x plus x as it is. Here plus is there, no? Here plus is there. If plus is there, what you have to write? Into. You remember this logic, okay? Into. By multiplying a variable with what number gives as it is, give the same number. That is meaning if I have 5, I have to multiply it with some number. The answer must be 5 itself. So that is 1. So I am multiplying it with 1. Okay. Next, x plus x into 1. You got to know why I wrote the 1. Fine. X plus x as it is. 1 is replaced with x plus x bar. If I replace it with x plus 1, I'll show you here. Okay. In this step, if I replace x plus x into 1, x plus x into, in place of 1, if I write 1 plus x, in place of 1, if I write 1 plus x or x plus 1, if I try to use this theorem, what I'll be getting? X plus x in place of x, x is there. In place of y, x. In place of z, x. So x plus y into z. Y is x, z is 1, which is equal to x plus x into 1 is x. X plus x. We are getting the same LHS, right? But what we have to get? We have to get the RHS, right? Okay, understood why I didn't use the x plus 1 in place of 1 while solving this. Fine. Next, we use these identities and solve. Next, I'll show you for the second problem. The second problem, b x into x is x. b x into x is equal to x. What I have to do? The first step is LHS, x into x. They'll ask to prove this using the basic identities. Fine. Into is there. In the next step, what I have to do? If there is into, what I have to do? Plus. What number I have to write here? Let me consider. I am having number 6 plus which number I have to add to this 6 such that the result won't be changed. It is 0. Very good. So in the next step, x into x, into is there. So take an OR, dual of it. Next 0, x into x as it is, plus in place of 0 what I can write? In place of 0 replace it with x into x bar. Fine. I cannot, if I replace this 0 by x into 0, we will again end up with LHS. So what I have to replace? 0 by x into x bar. X into x bar. Fine. Now, the given statement x into x plus x into x bar. This is in H form. See this one. X into y plus x into z. In place of x, I am writing here xy plus xz. This can be replaced as x into y plus z, or you can consider it as I am taking x as common. Both the sides, in both the terms, not both the sides, in both the terms x is common. I have taken x outside. X plus x bar. What is x plus x bar? You have to keep this formula sheet or this 10 identities with you always while solving the problems. Okay. What is x plus x bar? It is 1. So x into 1. What is 1 into x? What is 1 into x? It is x. Okay. So is it proved? Is equal to RHS Thus it is proved. Fine, you understood. In this video we solved the first two problems. Prove the following by using basic identities. By using basic identities. Fine. You can try to solve these 4 problems on your own. In the next video I'll explain how to solve these problems also. Okay. If you find this video helpful, do subscribe to our channel, do follow us and share with your friends also. Thank you for watching. Happy learning.